The next step in our RCM study is to add current and proposed maintenance tasks. To do this, we select a cause to which we want to add the maintenance tasks and double-click to open the Cause Properties dialog. In the Cause Properties dialog, we can select the Maintenance tab to add our maintenance tasks. Maintenance tasks come in one of three categories: corrective, planned, and inspections. Corrective tasks are performed in the event of asset failure. Planned maintenance tasks are performed to prevent failures before they occur. Inspection tasks are to look for imminent or dormant failures. We'll start with corrective tasks. Each cause may have one and only one corrective task. To edit the corrective task, I simply select the CM1, or whatever the task ID happens to be, and select Edit. In the task properties, I can assign a description and a task ID. Both of these are notes fields, so are not required or used by the analysis, but are helpful for the user to understand what this task represents. The task duration indicates how long it takes to perform the task. The ramp time is how much additional time it takes for the component to become operational again. This can allow for startup time once the task is completed, or cooldown time before the task begins. Together, the task duration and the ramp time account for the time to repair the component after a failure. There's an additional time that may be factored in there, that is the logistic delay time on the resources, which we'll talk about in just a minute. The operational cost is any miscellaneous costs associated with performing this maintenance task. Most costs are accounted for in the effects, as we saw earlier, or in the resource costs. Operational costs would be anything miscellaneous not accounted for in those other categories. For this task, I'll enter a task duration of 48 hours. Next, we'll add resources. Resources are the items that are needed to complete the maintenance task. This includes the labor that performs the task, any specialized equipment or tools that they need, and the spare parts that they use to replace the broken components. We'll start by adding labor categories. To add labor categories to the maintenance task, I'll click on the Add a Labor Resource button. In the Labor Selection dialog, I can choose a labor category. In this project, we haven't created any labor categories yet, so we'll have to add a new one. I can add a new labor category by selecting the Add a New Labor button. The Labor Properties dialog is where I will define the properties for this labor category. The ID and description are notational to indicate what labor or personnel this represents. In this example, this will be a fitter. The corrective logistic delay is how long it takes the labor personnel to arrive in the event of an unplanned outage or for a corrective maintenance. In this case, I'll set an 8-hour logistic delay. The corrective callout cost is how much additional money we must pay in order for the labor category to come to an unplanned corrective maintenance task. In this particular example, we have a $100 corrective callout cost. Scheduled callout cost is the same thing except for scheduled maintenances, that is, planned maintenance and inspections. The cost rate is the cost per hour or per time unit of this labor category. In this example, I'll use a cost rate of $20 per hour. The number available is grayed out. It's not used in the RCM cost module, but is only there for compatibility with the AVSIM module. Once I've filled out the properties, I'll click OK to add that labor category to the project. Now that it's been added to the project, I can select it and add it to the maintenance task. In addition to simply selecting it, I might want to specify how many are required to perform this task. I can also set the task duration. I can also set the active time. The default is the active time is set to the task duration. That is, the labor category is there as long as the maintenance task is being performed. In certain cases, I might set a separate active time than the task duration. This would be for a worker who's only there during part of the maintenance task. Once I've chosen my labor category, set my quantity and the active time, I will select the OK button to add that labor category to the maintenance task. Equipment can be added to the maintenance task in a similar way by selecting the Add an Equipment Resource button. Equipment, it's important to keep in mind here, refers to the items or tools that are needed in order to perform the maintenance task. Equipment does not refer to the assets themselves. So for example, this is a drive shaft shears failure mode on a screw feeder asset. So the equipment here is not the screw feeder or the drive shaft, but rather any tools that are required to repair the drive shaft on that screw feeder. Since I don't have any equipment defined, I'll select the Add a New Equipment toolbar button to add one. Equipment properties are identical to labor properties. That is, I can set the corrective logistic delay, how long it takes to get one to the site of the repair, corrective and scheduled callout costs, and a cost rate. For example, if we're renting the equipment, how much do we spend per hour to rent it? This particular maintenance task that I'm defining doesn't require any specialized equipment, or at least no equipment that I want to track. So in this case, I'll just select the Cancel button to dismiss both dialogues. The final resource category that we can add are spare parts. I'll select the Assign a Spare button to assign a new spare part. The spare parts are the actual items that are being swapped out. So in this particular case, the failure mode is drive shaft shears, so the spare part would be a spare drive shaft. I can add a new spare part by selecting the Add a New Spare button. There are a number of properties that we can define for spare parts, although only a few are used in RCM cost. The majority of the properties are for compatibility with the RCM module, so we will just cover them in passing. Firstly is the ID and the description, as expected. Next is the unit cost. The unit cost is how much each spare part costs, and it's used for tracking the amount of money spent on spare parts. Volume and weight are two alternative ways of tracking the cost of the spare parts. Instead of entering a cost directly, we could specify how much volume or how much weight the spare part takes up, and then in the project options for RCM cost, there's an option to track the costs by volume or by weight. In this example, I'll enter the spare part cost directly. The level 1, 2, and 3 tabs indicate spare storage levels. We can track where are we keeping the spare parts and how many we have available. Level 1 is generally thought of as the on-site spare parts. We can specify how many we keep on hand, the cost rate to store them, and the logistic delay time to get it from level 1 to the site of the repair in an unplanned maintenance task. In this example, I'll suppose a storage cost rate per drive shaft of $1 per hour per drive shaft. The logistic delay time we'll set at 48 hours. That is, once the failure has occurred, it takes us 48 hours to get it from level 1 storage to the site of the repair. Level 2 is generally thought of as off-site or warehouse storage. We can specify how many we keep on hand here, the storage cost rate per unit at level 2, and the logistic delay time to get a spare part from level 2 to replenish the used spare parts at level 1. In this example, I'll use a storage cost rate per unit of 10 cents per unit per hour, and a logistic delay time of 96 hours to get the spare part from level 2 to level 1 to replenish them as they're used from level 1. In this example, I'll leave the capacity for both spare parts at 0. RCM cost has the ability to optimize how many spare parts we should keep on hand, and we'll take a look at that optimization later on. Finally, level 3 is thought of as the manufacturer or the factory for the spare parts. Most of these options are pertinent to the RCM module. In RCM cost, the only option that's used is the logistic delay time. That is, if we run out of spare parts at level 1 and level 2, how long will it take to order additional spare parts from the factory? In this example, it will take me 480 hours to order an additional spare part. Once I've set the spare options as I want, I'll select OK to add that spare part to the project, and then I can select it, select the quantity of spare parts that I need to perform this repair, for instance if I needed multiple drive shafts, and then select the OK button. On the Advanced tab, we can set additional properties of this maintenance task. These include things such as the condition after repair, whether or not the maintenance task restores the unit to a condition as good as new, or as good as old. That would be if the maintenance is just a patching it up and not actually replacing the unit, or some intermediate level of repair where the unit is somewhat refurbished but not completely new. If we set an intermediate condition after repair, we can specify an age reduction factor, indicating how much the component's age is reduced by the maintenance task. We can also set properties pertaining to the task duration. The default settings would be a fixed task duration. That is, on the General tab, I entered a task duration of 48 hours, and by default, that would be assumed to be a fixed duration, meaning every single time this maintenance task is performed, it will take exactly 48 hours. In real life, that task duration may vary each time we perform the maintenance task, and so we can select a task distribution of exponential, log normal, normal, or Weibull. Based on the distribution we've selected, we'll also have additional settings, such as a standard deviation that we may need to set to define the task distribution. Once we've filled out the task properties to our satisfaction, we'll select the OK button to update them. The next task type is planned maintenance tasks. Planned maintenance tasks are maintenance tasks that are performed to mitigate or prevent failures before they occur. You may have multiple planned maintenance tasks assigned to a single cause. This could be because you have multiple tasks that can be performed, for instance, a frequent but cursory maintenance task and also a less frequent but more thorough task. Or it could be because you want to compare the efficacy of two different types of planned maintenance tasks. To add a planned maintenance task, you can select the Planned node in the task tree and select the New button. The planned maintenance task properties have much in common with the corrective maintenance task properties. In fact, there is a Copy Corrective Properties button. Often, the planned maintenance task is simply the same as the corrective maintenance, but performed on a schedule. When I select the Copy Corrective Properties, RCM cost will prompt me if I'm sure. If I select yes, it will copy the task duration, the resources, and any advanced properties that I may have set in the corrective action. The other properties that I can set for the planned maintenance task primarily revolve around the frequency that the task is performed, that is, the maintenance interval. Later on, we'll see how RCM cost will help us optimize this, but for now we'll fill out something to get started. The interval box is how often this maintenance task is performed. If this is a current task, it would be how frequently we're currently performing it, and of course RCM cost can help us optimize that value. The maintenance offset is added to the interval of the first maintenance task in each simulation. This is often seen when we have parallel components that are performing a redundant function. We don't want to perform planned maintenance on both assets at the same time, so we will add an offset to one of those maintenance tasks. This is not as frequently used in RCM cost, where we don't really consider the different assets as being in parallel with each other, and is primarily for compatibility with AVSIM. The fixed interval checkbox indicates whether or not the maintenance task is performed by the calendar or by component age. If fixed interval is checked, that means the maintenance is performed on the calendar, so in this case, it would be performed every calendar year. If it's unchecked, it's based on component age, meaning only when the component has operated or accumulated 1 year of age would the maintenance task be performed. How quickly the component ages is determined by the non-operating aging apportionment and the duty cycle as set on the Failure tab of the Cause Properties dialog. When we select fixed interval, we also have the option of specifying a minimum age. That is, we do maintenance at a fixed calendar interval, but only so long as the component is a certain age. The Task Enabled checkbox tells RCM cost whether or not this maintenance task is in fact performed at that interval. If I uncheck Task Enabled, that doesn't mean this maintenance task will never be performed, it's just not performed at a regular interval. It can still be a condition-based maintenance. If it is a conditional maintenance, we can set it as a secondary action task on the Advanced tab. Secondary action tasks are maintenance tasks that are performed in the event that an inspection task detects a failure is imminent. For instance, we might perform a replacement of the component, but rather than just doing that on a fixed interval, we might first check to see if the component is about to fail, and if it is about to fail, then we'll perform the planned replacement. We would define an inspection maintenance task to show how often we're checking to see if it fails, and the planned maintenance task would be the procedure that's performed when we detect that a failure is imminent. Non-operational during maintenance is how we tell RCM cost whether this component is considered unavailable while this maintenance task is being performed. The majority of planned maintenance tasks I would expect to be non-operational during maintenance. That is, they can't be performed while the component is operating. But in certain cases, on certain systems, you may have a maintenance task that is performed online, or at least doesn't cause any additional downtime. For instance, if the maintenance is performed during a scheduled plant turnaround. The system is offline anyways, so performing the maintenance task does not cause any additional unavailability that we need to keep track of. The mandatory task checkbox does not affect the simulations at all and is simply a notational option. When done, I'll select OK to add the planned maintenance task. As mentioned earlier, we can have multiple planned maintenance tasks. In this particular example, I will only define that one. Finally, we can also define inspection tasks. Inspection tasks don't actually correct anything. Rather, they're to inspect the component to see if some maintenance may need to be performed soon or if a dormant fault has occurred. To add a new inspection task, I'll select the inspection node and then click the New button. Inspection tasks look a lot like planned tasks. We have many of the same options in terms of the task interval. There are two primary differences. One, spare parts may not be assigned as a resource. This is because the inspection task is not actually replacing anything. Rather, the inspection is to look to see if a replacement may need to be performed soon. The second thing that we might want to set is the predictive data. The predictive data is how far in advance of a failure can this inspection detect a failure. The main data that we would use for that would be the PF interval. The PF interval is how far in advance of a failure can we detect it, and the detection probability, which is the likelihood of detecting the failure if this inspection is performed within the PF interval. The PF curve allows us to specify how that detection probability increases the closer to the time of the failure that the inspection is performed. Options for the PF curve include step, exponential, linear, and normal. You can check the help file for further details on the equations used to determine the detection probability based on the PF curve. Let's fill out this inspection task with some properties. I'll set a PF interval of 120. That means so long as this task is performed within 120 hours of a failure, we have a 100% chance of detecting it. I'll also set some properties on the General tab. We'll set the task duration as 0.1 hours, and we'll add our fitter as our resource. Once I've filled out the task properties for the inspection, I can select the OK button to add it to the cause. As with planned tasks, you can add one or more inspection tasks. Alternative methods exist for adding maintenance tasks to a project. The main method would be to reuse maintenance tasks that we've already created. These maintenance tasks could come from the same project or from another project. In another course module, we looked at attaching libraries, that is, using another availability workbench project file as a library. We looked at how to copy the locations hierarchy from a library into our project. We can do the same thing for maintenance tasks by using the Copy Task from Library button. If I have any libraries attached to this project, their task library will show up in the dropdown right here. And when I select Copy Task from Library, it will show me the locations from the RCM cost module and the failure models from the AVSIM module and all associated maintenance tasks. I can find a particular asset and a particular cause and select a maintenance task and copy it from that project. For planned and inspection tasks, it will add it as an additional maintenance task. For corrective tasks, it will overwrite the existing corrective task properties. Let's take a look at the last few tabs in the Cause Properties dialog. The Alarm tab allows me to specify that a condition alarm is installed on this asset. The condition alarm functions similarly to an inspection task. That is, it can detect imminent failures before they occur. We can specify a PF interval and a detection probability as we could for the inspection tasks. We can also specify the capital cost and the cost rate for having the alarm installed. We might use this, for instance, for the bearings worn failure mode over here to indicate that there might be a vibration monitor installed that indicates when the bearings are starting to break down. The Commission tab is how we can indicate that commissioning is performed on the asset before it's put into service. On the Failure tab, if we've defined a tri-Weibull distribution, as we have here, the first part of the bathtub curve usually indicates infant failures, that is, a period where the failure rate is higher than normal due to manufacturing, installation, or calibration defects. One way to get rid of these defects is to perform commissioning, that is, to burn in the component and run it before we put it into service. Commissioning can help eliminate these early life failures. If we perform commissioning, we have to indicate the period for which commissioning is performed, and also the costs associated with the commissioning. The Redesign tab allows us to track any costs associated with outright redesign of this component. Finally is the Strategy tab. This is where we'll actually perform the maintenance optimizations. We will cover this in the next training module. Finally, any maintenance tasks that you've added to a cause can be seen in the grid view by selecting the tasks tables. So for instance, the corrective tasks, the scheduled tasks, or any of those task resource assignments can be seen as well.